Hey there, this is Mr. Alexander, and today we're going to talk about truth tables with three variables, and we're going to ask the question, is a given argument a tautology, a logical contradiction, or neither? So, let's just jump into it. We're trying to get from P, Q, and R to not P and Q or not R. So the first column we need to make is this P and Q column. And that's only going to be true when both P and Q are true. So this is true, true, and the rest are going to be false because I don't see any double trues for the rest of those. Next, I want to make the not P and Q column, which is just the logical opposite of this. So it's going to be true, two falses followed by the rest true. False, true, true, true. And then finally I want to make the not R column, which is going to be all these R's. The truth value for the R's here, we're just going to flip them. So it's going to be false, true, false, false, true, true, false, true. And then finally, we're looking at this column or this column. So that means at least one true for or. So that means false, true, 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 true. So it's almost a tautology. A tautology is when it's all true. But we have one false here, so this is a neither. Tautology is all true. Logical contradiction is all false. This was neither of those two things. I'm going to skip ahead to question 4 here, and I'm looking at not P and Q and P and Q and R. So let's start with the P and Q first. And again, this is when both P and Q are true. So I'm going to have two trues here and the rest false. And then I want the negation of that, which is going to make this false, false, and then all true. And then I've got this P and Q and R thing, which is only true when all three of them are true. So that's going to be true followed by a whole bunch of falses. True, false, 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 false. And then I'm looking at these two columns here, and I see an and symbol. So that means they both have to be true. And you can see that happens nowhere. These are all falses. Which means that this argument is a logical contradiction. It is always false regardless of what P, Q, and R represent. Whether or not they're true or false, this argument, this statement, this compound statement, is a logical contradiction. Always false. Okay, one more. And this one's shorter. This one only has P's and Q's in it. So I want to start with the P and Q. And that's only true when P and Q are both true. So that's true, false, false, false. And then not P and Q. It's just the negation of that. So false, true, true, true. And then I've got P or Q, which means at least one true. So true, 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 false. And then this is this column or this column. So at least one true, which means these are all trues. Which means that this argument is a tautology because they're all true. And that's pretty simple. That's the whole thing. That's how you fill in these truth tables. So thank you for watching. We'll see you on the next one.